In this problem, we want to predict products with phases. We want to balance the equation and write complete and net ionic equations. Before we do this problem, it's a good idea to go back to your notes. Go read the notes on double displacement reactions and the solubility rules. So what we have here are the reactants. Silver nitrate, AQ, stands for aqueous. That means that silver nitrate is in solution. And this solution will react with another solution of sodium chloride. Notice sodium chloride has the same phase, AQ, for aqueous. So what we want to do first is predict those products. This is where we implement this double displacement type of reaction. So usually when we have these solutions with these ions present, when they mix, usually they'll undergo this double displacement process. And so an easy way to remember this is just swap those anions. And so the first thing we'll do is we'll identify the ions present. And so the silver nitrate, remember there are silver ions present and there are nitrate ions that are present. In the sodium chloride solution, there are sodium ions present and there are chloride ions that are present in solution. So let's swap those ions and write the products down. So on the product side, here's the silver, but instead of the nitrate, I'll write a chloride ion. And the other product will be the sodium, but instead of the chloride, I'll write the nitrate ion. Now notice that I'm writing the ions with those charges. So now what I want to do is write the formula. So what does a silver ion and a chloride ion, when they combine together to make this ionic compound, how would we write that formula? So remember back to our writing formulas, we want those charges to balance. Silver's a +1, chloride's a -1. So those charges do balance. So the silver chloride would look something like this. AgCl. Sodium nitrate. Sodium's a 1+, nitrate's a 1-, +1 -1. Those charges balance. So the formula for sodium nitrate would look like this. Next, let's write the phases. You'll have to go to the solubility rules, which you can find in your notes, and you'll see that if you follow the chloride on that chart, you'll notice that chloride is soluble with most ions. One of those exceptions is silver. So when you see a silver chloride, this is slightly soluble or insoluble. That means that it forms a solid. It does not dissolve in solution. So I write that S there to indicate that silver chloride is a solid. The sodium nitrate, if you go to the solubility rules, you'll see that the nitrate is soluble with pretty much anything. And furthermore, on those solubility rules, you'll notice that the sodium, again, is soluble with pretty much anything. So next to the sodium nitrate, I'll write AQ. So we've predicted the products and we've written down the phases. Now balance the equation. If you look carefully, of course, you'll notice that everything is balanced already. So the mole to mole ratio for these species is all 1:1. Okay, so this is called the formula equation. It's called the formula equation because we're writing the equation using the formulas for all these compounds. Now that's fine, and we'll use this formula equation when we do stoichiometry. But there's some other things that are important to us. The complete and net ionic equations. So let's write the complete ionic equation first. In the complete ionic equation, the thing to remember is we want to write all of these species the way that they would look in solution. Let's start with the first species, silver nitrate. Silver nitrate is aqueous. That means that this is the way we write the formula, but this is not the way silver nitrate exists in solution. Because it's aqueous, it actually exists as silver ions in solution and nitrate ions in solution. And notice that I wrote 1 silver because in the balanced equation there's 1 mole of silver nitrate. So when 1 mole of silver nitrate dissociates, there's 1 mole of silver and 1 mole of nitrate. For the sodium chloride, aqueous, again, we'll go ahead and write those ions that are present. There's 1 mole of sodium chloride in the balanced equation, so we'll write 1 mole of sodium and 1 mole of chloride. On the product side, silver chloride is solid. So silver chloride does not dissociate when the solutions are mixed. Silver chloride is produced and it's in the solid phase. So for solid, we'll go ahead and leave the silver chloride together because that's the way it is in the end. The sodium nitrate aqueous, we'll go ahead and write it as sodium plus AQ. And I'm running out of space here, so I'll write the nitrate down here. So the sodium nitrate is split up because it's aqueous. So in the end, after all of this is mixed, this is what we get. The sodium and the nitrate are in the aqueous phase. This is the complete ionic equation because it gives us a complete picture of what's actually in solution. Now, the net ionic equation. The net ionic equation, just like a math problem, is we cancel out what appears on both sides. Whatever's left over is the net. So look at the yield sign, and then on either side of the yield sign, notice what appears on both sides. The sodium aqueous is present on the reactant side. Notice that in the end, after everything has mixed, we still have sodium aqueous. You also see the nitrate. It's aqueous at the beginning, and then after the solutions have mixed, the nitrate is still aqueous. So the sodium and the nitrate don't do anything. Those are called spectator ions. Spectator ions because they don't do anything. But look at this. The silver aqueous and the chloride aqueous are not present on the product side. Yes, there's a silver chloride solid, but this is not silver aqueous and chloride aqueous. The silver chloride is together. So notice that the silver, the chloride, the silver chloride do not cancel each other out. So the net ionic equation is we write down what's left over. So just so there's no confusion here, the net ionic equation is this. The sodium and the nitrate are spectator ions. So quick recap. We identified the ions present so that we can do this double displacement reaction and write the products. We use the solubility rules to include the phases, and we balance the equation. That's called the formula equation. By identifying those species that were aqueous to begin with, we wrote the complete ionic equation. The solid species stays as a solid in the complete ionic equation. By canceling out what appears on both sides, we were able to cancel out the spectator ions. Whatever was left over is our net ionic equation. So this is the chemistry. This is what actually happens when silver nitrate and sodium chloride solutions mix together. This is the second video where I'll show you how to predict the products, write phases, and balance the equation of these precipitation reactions. Now I'll also show you how to write the complete and net ionic equations. So in this example we have K2S, this is potassium sulfide. AQ stands for aqueous. The second reactant is a solution of nickel nitrate. Now nickel is a transition metal, and so remember this is called nickel 2 nitrate. How do we know it's nickel 2 nitrate? Remember from chapter 2, with the transition metals we need to know what the charge is. So nickel is one of those transition metals. I don't know the charge, but I do know the charge of the nitrate. Nitrate is always a -1. There are 2 nitrates. That means in order for those charges to balance, the nickel has to be a +2. So that's how I know it's nickel 2 nitrate. This is also aqueous, so that's why I said that this was a solution, because that's what aqueous means. Okay, so let's identify the ions that are present in solution. Potassium sulfide has potassium ions and sulfide ions. The nickel nitrate solution has nickel ions, and it also has nitrate ions. And so remember, when we have these solutions mix, what typically happens is we get this double displacement process. Easy thing to remember is let's go ahead and swap those ions. So those anions, we'll go ahead and swap them. So on the product side of the yield sign, we want to write those species. So we'll write a product with potassium, but instead of the sulfide, we'll write the nitrate ion. And then the second product, we'll write the nickel, but instead of the nitrate, we'll write, the sulfide. So now that we identify the ions present on the product side, let's go ahead and write those formulas. the formula for the first product is K plus NO3. We want to write that formula where the charges balance, +1, -1, so we just need one of each. KNO3. Our second species, nickel 2+, sulfide 2-, we want to write a formula where these charges will balance, 2+, 2-, so we just need one of each. So those are the two products. Now let's write the phases. You got to go back to the solubility rules and you'll see that the potassium nitrate is soluble. Soluble means aqueous, that it dissolves in solution. The nickel sulfide, you'll notice nickel is soluble with those cations of group 1, ammonium, and a couple of other ions, but nickel is not one of those ions. And so sulfide is going to be insoluble when it's complexed with the nickel. So insoluble means it doesn't dissolve. So we're going to write an S to represent solid. Okay. At this point, we've written the products with the formulas and we've written the phases. Let's balance the equation. We need a balanced equation in order to do stoichiometry. You notice that the equation is not balanced. So just to balance by inspection, inspection just means look at it. There's 2 potassium. Over here there's 1 potassium. There's 2 nitrate. Over here there's 1 nitrate. So we'll balance by writing a 2 in front of the potassium nitrate. And so what we've done here is write down the formula equation. Okay. So now let's move over to the complete ionic equation. Now, if you remember the first video, I go into detail on how to write the complete ionic equation. So I'll just summarize that here. Every time we see an aqueous, we see 3 of them here, what we want to do is separate those species, those ions, so that we can have a better representation of what's going on in solution. So for example, right here, K2S. When this thing dissolves in solution, watch very carefully. 2 potassium ions will dissociate for every 1 unit of compound. So let's think in terms of moles. For every 1 mole of species, there are 2 moles of the potassium ion. So in the complete ionic equation, I'll write 2 K plus aqueous. For every 1 mole of the potassium sulfide that dissociates, there's 1 mole of the sulfide that dissociates. Look at the nickel nitrate. For every 1 mole of nickel nitrate, there are 2 moles of, 1 mole of nickel that dissociates, 2 moles of nitrate that dissociate. Okay, let's look at the product side. On the product side, notice how there's 2 moles of potassium nitrate aqueous. So when 2 moles of potassium nitrate aqueous dissociate in solution, there are 2 times 1, 2 moles of potassium, and 2 times 1 nitrate, so 2 nitrates. that dissociate. Whoops. There you go. And finally, remember what we did last time. Whenever there's a solid, remember that solid is being produced. That solid is a solid compound after the solutions have been mixed. So the nickel and the sulfide are not in solution anymore, but rather they're forming this solid compound. So in the complete ionic equation, we're going to leave the nickel sulfide together. And that's the complete ionic equation. What's the net ionic equation? You think of this equation like a math equation. You look on either side, whatever appears on both sides, they'll cancel out. And the net is everything that's left over. You'll notice there's 2 moles of potassium at the beginning. After the solutions have mixed, there are still 2 moles of potassium. There's 2 moles of nitrate at the beginning. After the solutions have been mixed, there's still 2 moles of nitrate in the aqueous phase. So these ions that cancel out are called spectator ions. K plus and nitrate are spectator ions. They don't do anything. Now, look at the nickel and the sulfide. Nickel and sulfide are ions in solution to begin with, but at the end, they form a complex. They're not aqueous anymore. There's nothing to cancel here. So our net ionic equation I'll write the cation first, because that's what we're used to, writing the cation first. So our net ionic equation is nickel reacting with sulfide to yield nickel sulfide. Nickel 2 sulfide, sorry.